Continuing with our checklist for my function. Let me remind you the function fx equals 3x to the power 5 minus 7x to the power 4. Okay. Intervals of increase or decrease. Okay. To find intervals of increase or decrease, we first need to find critical numbers. Find the derivative. What are critical numbers? Where the derivative is 0 or the derivative is undefined. My function is a polynomial, right? So its derivative is also going to be a polynomial, and therefore that is going to be defined everywhere. So undefined is not an option for me because right now we are polynomials. Okay. Now, so the only other way of getting critical numbers is when the derivative is 0. So find the derivative of this. Derivative of this function is, well, bring the 5 down, 15, bring the 4 down, 28, reduce the degrees. So we found the derivative 15x to the power 4 minus 28x to the power 3. Get x to the power 3 out, you get 15x left over minus 28. Why did I get it out? I want to set it to 0. Factoring, I have x cubed, 15x minus 28 equals 0. Solving for this, x cubed is 0 and 15x minus 28 is 0. So x cubed fetches me x equals 0. Whereas here, I have to move the 28 over and divide by 15. In other words, I get x equals 28 over 15. You notice I'm dividing this to write it in a mixed number form, 1 and 13 over 15, so I can estimate where this lies. This is a little more than 1. In fact, a lot more than 1, but a little less than 2. Okay. So 28 by 15 is closer to 2. 1 is here, 0 is here. So this is one particular critical number and this is the other critical number. These are very important critical numbers. So keep these in mind. Question is, where is my function increasing, decreasing, increasing? How do I know this? Well, the only way to know this is use critical numbers. With these two numbers, you can cut the real number. These are your cut points. If I cut the real number along these two numbers, what do I get? Negative infinity to 0, one interval, 0 to 28 by 15, another interval, and 28 by 15 to infinity. That's the third interval. Choose a number from each piece. From this piece, I did not write it. From this piece, I choose test point number -1. From the second piece, I get test point +1. From the third piece, I get test point 2. I just chose these numbers. Okay, guys, if you like, you could have taken -10 here and 20 here. It doesn't matter. Choose any test point from each interval. Use that test point in the expression for f prime. Okay, it's better if you use the factored expression because all we are looking for is the sign of f prime. So plug in -1 here, -1 power 3, 15 times -1 minus 28. Observe carefully, this will give me a negative. All of this together will give me a negative. Do you see that? -15 minus 28. Negative times negative, overall positive. In other words, my fx in this interval is increasing. Hence the arrow is up. Okay. Likewise, from 0 to 28 over 15. We know, we estimated just here, 28 over 15 is 1 and 13 over 15. In other words, it's to the right of 1. Okay, so we have chosen a test number there. Plug that guy in the derivative function. 1 cubed, 15 times 1 minus 28. So that's a positive. This is 15 minus 28. I don't care what the value is, but it's a negative. In other words, my function is decreasing on this interval, hence the arrow going down. On this interval, my function is to go down. Likewise, the last interval, 28 over 15 until infinity. Well, that is slightly before 2, so I have chosen test point 2. Plug it in. 2 goes there, 2 cubed. 15 times 2 minus 28. So that's a 30 minus 28, positive, positive, positive. So on this interval, I'm going to go up. So notice what that means. 0 is a critical number. I got slope 0, that is my tangent is horizontal. 28 over 15 is another, tangent is horizontal. What happened to the left of 0? I was increasing. What happened to the right of 0? I am decreasing. So 0 gives me a local max. Likewise, 28 over 15, horizontal tangent. What happens to the left of 28 over 15? I'm decreasing. What happens to the right of 28 over 15? I'm increasing. So this gives me a local min. Okay. 0 gave me a local max. Plug in your fx to give you the value 0. The point will be 0, 0. Okay. Likewise, take this 28 over 15, plug it into fx. Okay. I've done this calculation, blah, 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 and I get this value. So the local minimum is with a negative 16.99 whatever. So this is a local minimum value. Okay. Now, there is a second derivative test for local maximality or minimality. Find the second derivative. You have the first derivative. Where did it go? First derivative was this guy. Find its second derivative. So the 4 comes down, 60. 3 comes down, 84. Where is the second derivative? 60. X to the power 3 minus 84 x to the power 2. You have two critical numbers. One was 0, the other was 28 by 15. Plug it in the second derivative. When you plug it in the second derivative, for 0, I get a 0. So second derivative test cannot be used. Okay? Cannot use a second derivative. See, second derivative test is good if it's positive or negative. Now let's try 28 over 15, the second critical number. If you calculate, which I have done here, I get a positive value. That tells me f is concave up. You can see that in the picture, it's concave up, which gives me this is going to be a local min. Okay. Now, why did it fail for 0? Yeah. It looks like it's concave down, but the fact is all critical numbers are not the same. Chances are my 0 is so flat that even the second derivative is 0. Okay, so second derivative test can only be used when the value is not 0. If you get an answer of 0, then second derivative test is not useful. Okay, I'll come back to concavity and points of inflection in the next video. Okay, until then, bye.